Hey everybody, here we go. Unit 11, lesson 1. We are starting what we call sequences, okay? So, sequences a lot of times are just looking for patterns. It's nice and easy. It's not a terrible chapter. So let's get started. For your do now, it says describe the pattern you see in each sequence of numbers, okay? So I'm going to check to see, all right, what do I notice to get from 5 to 8, from 8 to 11, 11 to 14? It has to be the same thing every single time to follow the pattern. So I'm going to do plus 3, plus 3, plus 3. So it adds 3 as the pattern. Okay, I'm going to do the same thing over here. How do I get from 5 to 3 and then 3 to 1 and then 1 to -1? I take 2 away every single time. So it subtracts 2. Okay, another way to say that is it adds -2. Okay, these are synonyms of one another. They are exactly the same. Okay. Here to get from -4 to -2, from -2 to 0, from 0 to 2, I'm going to keep adding 2 every single time. Okay, so those are the patterns there. All right, moving down to your notes, I'll discuss this a little bit. We have a sequence, okay? These are all sequences. They keep going on and on. Is an ordered list. Each number in a sequence is called a term, right? So this is a term, this is a term, this is a term, this is a term, this is a term. An element or a member, okay? So there are 3 different ways you'll hear that, but for the most part, we'll be saying the word term. Terms are referenced in a subscripted form written below. I'll go over that in a moment, where the natural number subscripts refer to the location or position of the term of the sequence. So for example, if I have this sequence here, 1, 5, 9, 13, 17, 21, so on and so forth, it keeps going on and on and on. We use the letter A to represent the sequence, the notation for the sequence. And then we need to do a number for it, okay? And the position of this number is very important. It always goes in the bottom corner. If you put it in the top corner, it looks like you're trying to do some exponents. We're not trying to do exponents here, okay? The subscript at the bottom is telling me where it is. So the 1 is the first term in the sequence, okay? So it's A sub 1. If I keep going through here, the 13, 1, 2, 3, 4, that's the 4th term of the sequence. So they have a letter A and they do a little 4 in the bottom corner. That shows that it's the 4th term. The 4th term is a 13. Okay, so the first term would be A sub 1. That's how you say it instead of saying subscript. So it's A sub 1. Sub 1, again, shows me I'm putting it in the bottom corner. The subscripted 1 means it's the first term. The second term is going to be A sub 2. The third term is going to be A sub 3. So when I write it, I put the numbers in the bottom corner. The nth term, let me explain what nth means. That just means I don't know where on the list it is. It could be over here at the, I don't know what 10th term. It could be all the way over and over until the 100th term. I don't know exactly where it is. So we use the letter N to show that I don't know exactly where it is, but I know it's in this list somewhere. So that's going to be written as A sub N with the bottom, the N in the bottom corner. Okay. We can also represent them using function form, right? Because sequences are functions. If we were to plot the points of these, we're never going to fail the vertical line test. That's just essentially what that's saying there, okay? So if I use function form, this is going to be the first term, the second term, the third term. So F sub 1 is our first term. F of 2 is our second term. Our third term is going to be represented by F of 3. And our nth term is going to be represented by F of N. Okay? So I want you guys to realize that A sub 1 and F of 1, these right here are synonyms of one another. I hope I'm spelling this right. I think I forgot how to spell the word synonyms. I think that's right though. Okay, so that's your notes for today. We're going to continue on. We have this little chart here to help us out. Okay, we have this sequence 1, 5, 9, 13, 17, 21, which I think is the same as your notes right here. We're just going to be working with it a little bit. So term number 1, the term in that position is a 1. The subscript notation, so it's A sub 1. And the function notation is f of 1. Okay. In the second position, term number 2, here's term number 2. That's a 5. Okay, to show that I'm talking about the second position, it's A sub 2. Again, the sub just means we're putting a 2 in the bottom corner. Or f of 2. These are synonyms of one another. These are synonyms of one another. In my third position, I have a 9. In the fourth position, I have a 13. In my fifth position, I have a 17. Sixth position, I have a 21. And in my nth position, it keeps going on and on and on, okay? So I have terms going out to here. It keeps going on to infinity, adding the same number over and over and over. So right here, I'm just going to put an n because I don't know exactly what the term is. My nth term is represented by this, and the function notation is f of n. All right. So in the above example, what number do we add every time to get to the next number in the sequence? So what that question is asking is, what am I doing to get from 1 to 5? What am I doing to get from 5 to 9, from 9 to 13, so on and so on and so forth, okay? So what number do we add every single time? Keyword add. We're adding 4. So we'll talk a little bit of what we call arithmetic sequence. And you guys, tomorrow we'll be focusing on arithmetic sequences again. So this is not something that you have to master right today. Okay, so it says in an arithmetic sequence, the difference between consecutive terms that are next to one another, right? Consecutive months are January, February, March, April. They follow in order of one another. Is constant, okay? It has to be added the same thing every time. The number that you add over and over and over is called the common difference, and we use the letter D. So let's go back to this example right here. 4 is what we call the common difference in this sequence right here. Okay? If we were giving our answer, what's the common difference? We would say D equals 4, okay? Our common difference is represented by the letter D. It's as simple as that. So here, let's take a look. How am I getting from -7 to -3? And if you guys are kind of stinking with your positives and negatives, use your calculator to help you. Do some trial and error. Start with -7, add 2, see if you get to -3. If it doesn't work, you keep kind of messing around with it. That's okay. -3 to 1, 1 to 5, I add 4 each time, okay? So my common difference here is going to be a 4 again, all right? It will not always be a 4, I promise. All right. So what's the common difference to get from 1 to 1.5, 1.5 to 2, 2 to 2.5? What do they keep adding every time? Seems to me they're adding a 0.5 each time. So that means that my common difference is 0.5. Okay, it's just what are they doing to get from one to the other? This one's a little bit of a tricky one. So it's going from 10 to 8, 8 to 6, 6 to 4, so on and so on and so forth. So it's going down by 2. So it's subtracting 2 each time. So if I just said that D equals 2, sorry, it's a little sloppy. D equals 2, that would mean that I'm adding 2 every time. Okay, and remember, the common difference is what you're adding every time. Well, to show that I'm taking away 2, I'm subtracting 2 each time, I'm just going to throw that negative in there. Okay, just to show that I'm not going bigger. I'm not adding 2 every time. I'm actually going smaller. So we're technically adding a negative 2. Remember, subtracting is subtracting 2 and adding negative 2 are equal. These are synonyms of one another. Okay. So for example 4, they want you to state the common difference and then state the next 2 terms. Okay, so I have to figure out what are they going to get from here to here, here to here, here to here. It looks like plus 6, plus 6, plus 6. So my common difference is 6. So I'm going to continue that for 2 more terms. If I add another 6, oops, I'm going to have a 29. And if I add another 6 from there, I'm going to have a 35. Okay, here we go. 20 to 15, 15 to 10, 10 to 5. It looks like I'm going down by 5. So I'm subtracting 5, minus 5, minus 5, minus 5. So my common difference is negative 5. Okay, if I continue and I keep taking away 5, I'm going to go, if I have 5 of something, I take 5 away, I'm going to have 0. And then if I keep taking 5 away, keep going in the negative direction by 5, I'm going to go down to negative 5. This one's a little tricky because we have our negatives here. Just be careful, because the more negative I go, oops, sorry about that. The more negative I go, the smaller I'm getting. That means I'm subtracting. So technically, I'm subtracting 4 right here. That's a tricky one. Okay, so I'm going to keep subtracting 4. Okay, so if I subtract 4 again, I'm going to get a negative 19. If I subtract 4 again, I'm going to get a negative 23. Okay, so my common difference is negative 4. And my next 2 terms are going to be a negative 19 and negative 23. All right, example 5, they are looking for the 7th term. Well, I have 1, 2, 3. I have 4 terms right now. Okay, let's see what the common difference is. Plus 3, plus 3. So there's my pattern. Plus 3. Okay, so I have a sub 4. I now need a sub 5, so I can figure out a sub 6. I need a sub 6, so I can figure out a sub 7, and this is where we'll stop, because that's the 7th term. All right, 7th term is a sub 7. All right, here's a sub 1, a sub 2, a sub 3, a sub 4. I now need a sub 5 by following this pattern of adding 3. So it's going to be 14, add 3 again, that's going to be 17, add 3 again, that's going to be 20. And that's the answer to my question. Okay. All right, so for your closure, we're going to sum it up here. The diagrams below represent the first 5 terms. So here's my a sub 1, here's my a sub 2, a sub 3, a sub 4, a sub 5. I start with 3, then 6, then 9, then 12, then 15. So it looks like to get from here to here, I'm adding 3, so on and so forth. So that's my common difference. And then you're going to find the next 3 terms for your closure. And then you have your homework at the bottom. Okay, I want to see work from my kids. I want to see work. Don't just circle and give me an answer. Show me that you're starting with a 4 and a common difference is 3. Show me that you're adding 3 each time. And then make yourself a little list. They want to know what's the 5th term. So 1, 2, 3, 4, 5. This is where you should stop. And then you circle your answer there, okay? Or write out which choice it is. That's it. That's lesson 1 of the next chapter, folks. Good luck.